Hello, my name is Berger, and this is my submission for Lab 5. Choose your own adventure, the course Physics 2211 with Dr. Claire Berger. The purpose of my lab is to calculate the angle of an inclined plane by calculating the forces acting upon a ping pong ball rolling down the inclined plane. First, we analyze the motion of the ping pong ball rolling down the inclined plane with the video tracking software Tracker. Then, with the data from Tracker, we made a series of calculations to determine the angle of the inclined surface. Here, we can see a brief preview of the results of the lab. The main physics principles used in this lab involve Newton's second law and force decomposition. Newton's second law is used to calculate the sum of net forces on the ping pong ball in order to calculate unknown values, which in this case is the angle of the incline. You can see on the left side here. Force decomposition is used to rewrite the force of gravity in terms of ramp coordinates for ease of calculations, as you can see here. The system's surrounding initial conditions are such, where the system is the ping pong ball, the surroundings is the earth and the ramp, and the initial condition is that the ball is released from rest and that there is no friction between the ball and the ramp as the ball rolls without sliding. Before we move into the tracker, we must note that in order to calculate the angle of incline, the only unknowns we need to find in tracker is the final velocity of the ping pong ball, as well as the time spent in motion. Here we can see the unknowns that we need, where this is the final velocity, this is the time. We know the force of gravity, and we know that the ball is released from rest, which means the initial velocity is 0. Knowing this, we can now move into tracker. You can see the ping pong ball roll down the inclined plane. In order to find the final velocity of the ping pong ball, we could take the average velocity over a very small time interval. Here, we would take the last 2 times. With this information, we can easily calculate the final velocity of the ball, and therefore the angle of incline. In the middle, we can see the final velocity calculations, and with final velocity, we can see the acceleration calculations. And once we have all the unknowns, we can calculate the angle of the ramp, which turns out to be roughly 13.38 degrees. Possible sources of error for this lab are that the ball rolls, therefore it has angular velocity. But in the case of my lab, only translational velocity is accounted for because it's difficult to see how many rotations per second the ball does. Uh, Additionally, the ball bounces slightly throughout the motion, and the camera angle is slightly off. For my what if, I said, instead of using a ping pong ball, what if we use an object with a rough surface? Well, if we use an object with a rough surface, it would be impossible to find the angle of incline because we do not know the coefficient of kinetic friction for the object, as well as the angle of incline, leaving 2 unknowns to be solved for. Or what does it mean? How can we use this knowledge about inclined planes to determine other forces, such as friction? Using this experiment first, we can calculate the angle of the ramp. Then, with that knowledge, we can calculate another object sliding down the incline and use what we know to calculate the coefficient of kinetic friction of that object. And that math is shown here. And that wraps it up for Lab 5.